You can probably say, oh, that's a clean architecture. No, it's not. It's just because I see it this way. I can abstract UI from the core logic, but please don't get it wrong, it's not about that. So how our code will look like, or application structure. Let's see. Okay. Oh, by the way, it's getting hot here. So I think it's right time now. Here we are. I'm happy to be here. I'm kind of second time in Italy, but first time I actually spent just 2 hours in Milan, so it was a waste. I hadn't seen anything. I just burned my mouth with a coffee. That's it. Today, I'm happy to give a talk in front of you, though it's not going to be that fancy. I don't have all these animations and generated images. Yeah, I was lazy. But last night, I decided to change all my presentation completely, so probably we'll see something new. I don't know. Let's dive into it. Yeah, as you can see, it's about throwing the code out of the ring. Let me introduce myself. My name is Vladimir Pinchuk. If you don't know yet, that's amazing. I'm happy to see you, my friends here. First and first, I'm a developer, of course, and what I'm developing at, Android and Flutter. I switched to Flutter. Speaking and writing, as you can notice, but where? Just scan the QR code so you will see that all resources. I'm not like enforcing you to connect, but if you want and you want to ask some questions afterwards, feel free to. And also, as you can imagine, I'm not a native English speaker. I'm from Ukraine originally, but I live in UK and working at Sky. This talk, though, is not going to be connected to whatever I'm doing at Sky because NDAs, other things, it's not related. It's going to be about interesting things, I hope. So let's get into it. It's not going to be just a talk. It's going to be kind of a story. A story, how we all start the development. I will also play this raise your hands game. Can you raise your games? Can you raise your hands if you've started from Flutter, didn't switch from another technology? So Flutter was your first choice and the first framework, you know. Quite some people, not that much. So I can bet that others have some previous experience. Android, iOS, or web? Please raise your hands. Amazing. So we have experienced it and quite new people in the community. Happy to see that. And yeah, this talk will be pretty about how we build an application and how we build an application with all the restrictions we have. Time, I mean time and money, usually. Then we'll walk through the package selection because whatever we did before, it's not always perfect, but now we need to think wisely. And then what happens if we didn't think wisely? So actually, did we get into any trap, right? I will give a bit of intro about ports and adapters. I won't share much what it is right now because it's later. And I will show how we can actually throw dependencies out of the ring, starting with UI and then starting with a bit more complex solutions like routing, whatever. And then relax, test it easy. I hope you recognize this song, but it's not really that song. It's about testing. FYI, I was not TDD person before I've learned about this thing, because then I noticed like, oh, it's so easy actually to test stuff before you write it. So getting started. Started with essential things we are doing in the beginning. I don't see this code from here, but I hope you can see it clearly on the screen. Here we are adding just some state management in the beginning. I'm not showing specific packages, just it's not nice to say like it's bad. No, it's not bad. It's just a different approach. But you can probably recognize some patterns, so feel free to say like, yeah, I know this. We're adding state management. How it looks like, in the main we are adding scope, for example, or we're initializing something. Then we have a UI which need to navigate somewhere and to and to navigate, we are saying, UI model, please navigate us. UI model, to highlight, it's not about clean architecture. Model is just to kind of somehow split UI from UI-related logic. So this is whatever state management you will choose. It can be global or local. I do prefer local though, because it is kind of scoped really to the place where you need it. You used it, dispose, amazing. It's clean, it's neat. Global though is declared on the top of application, so you are scoping it somehow, but scoping globally. Afterwards, it's kind of hard to follow all the dependencies, all the things you declared all over your code, because you can declare it in different places. Anyway, we started, we did the state management, we add in router. We need a navigation, of course, because our application at least few screens, I hope, or it could be one screen with 3 tabs or whatever. But adding routing. Routing is usually just as well on top of the application. Yeah, I can barely see it here. But anyway. And for routing, as I said, you are speaking from UI through the model to do something. Our scheme looks pretty, not that way. Our scheme looks pretty like this. So UI says model, and model says like, yeah, I can navigate you somewhere. Please don't judge me, it's average. I'm not saying that's what I'm doing always, but sometimes for my own pet project, I can even call whatever router from UI, so please don't judge me. Highlighted with bold and white all the important points. Added routing, we need also remote storage, for example. And in this case, it's going to be something static. Static means globally available, globally accessible, and I've seen a lot of code examples where people just call it from wherever they want. Initialization is on top, of course. So you can see in main, we are initializing some static dependency. And then in best case, we are saying, model, please do that. Model talks to repository, because we don't really propagate any patterns here in this specific case. And the repository talks to this remote storage in ideal case. So average scheme, as you can see on the screen, is something like this. So screen, or whatever, UI model, then somehow repository, or whatever else you will call it, and then third party dependency. Again, it's super close. It's still inside of our application. And you can imagine you have quite a few repositories. Going forward, local database still works the same as the previous example, but in this specific case, we added a bit more interlayers. We had a database helper, and this helper talks to the database. Whatever database you choose, doesn't really matter. More or less, we are setting up all the dependencies we need for our application to work. One more interlayer, but still quite close. All dependencies are still quite close. Then, we can imagine we did it, it works. Nothing wrong with that. I'm not judging anyone. I was there as well. I was doing the same, and I'm still can do that. You can probably say, oh, that's a clean architecture. No, it's not. It's just because I see it this way. I can kind of abstract UI from the core logic, but please don't get it wrong. It's not about that. So how our code will look like, or application structure. Let's see. You can see on top there is a UI, then it talks through the model to whatever application services. We're adding theme. It's on UI level. That's amazing. But with that, we're adding some transient dependencies, right? These strange things with exclamation mark. We're adding maps, for example. It's also on UI level, but then we are grabbing another dependencies. Again, exclamation mark, we didn't know about it, or we haven't thought about it, but we have it. We're adding remote database. Remote database, more or less model up level, somewhere there, somewhere in between on the edge. It adds also some dependencies. And so on, WebSockets. Then we are adding connectivity, networking. We have a lot of dependencies. And for you to understand what kind of dependencies we have, you can actually just check your pub/spec log in the end, and you find out which dependencies are direct, which dependencies are transient. I'll grab a sip. Yeah, that's good to have water here. So, now I'm not closing. That's what we have. We are in control of some of these things like purple ones, but we are not in control of the yellow, and yellow can change. And as you're importing some packages, you're getting in a situation that you depend on something else, you're out of control. Out of control, like, kinda. And I'm not definitely happy of this. That's how I'm thinking, thinking, and another senior developer sitting on this, like, where we are and how we get here. It happened because we had limited resources, but let's revisit some things. Does it look familiar to you? Maybe no. Maybe that was not you. So, yeah, that was not me. It was not me. Actually, it was a guy who worked before me, and that guy already left the company, and now we have to deal with this, yeah. It's not me. Anyway, going forward, package selection. I will try to do it fast because most probably you will learn, you know about that, and you've already did that before. So I will just show some screens. No code, easy. Here we are. You probably can recognize the screen. Yeah, you can still see it. It's super dark. But we have some amazing package. Of course, yeah, of course I didn't use any. I didn't create it from scratch. I used some package. If you can understand what package is behind it, you'll probably get a present from me. It's a nice pin, nice 2 pins even. So think of it. I will accept answers afterwards. So whoever is first, and definitely, I mean, like, honest, I will give it to you. So amazing package, whatever, developer. Let's go through the points we need to consider. Here we are. First publisher. Some verified trusted publisher.dev with verified badge. Yeah, here we are. So first to consider if this is a company or it's a trusted community contributor, if this community contributor have really some, let's say, recognitions like GDE in 4 categories, for example, or this is a community contributor who just created a package and abandoned it. So that's first point to consider because you know whom to ping in case of any things. Ping means like reach out, of course, not to blame, no. Second thing, we are considering how many platforms this package or plugin supports, because probably you don't need all the platforms, but if you do, please check it out because like depending on the package which is not supporting crucial platforms is not the good choice. Then we are checking likes, we are checking pub points and downloads. That's kind of a valuable thing, but sometimes it could happen that packages are still not in the best shape. It could happen because something changed afterwards. What I mean, in the next version, they decided to add additional dependency, and these dependencies is actually malware. It happened already with one package. I'm not going to say which one, but again, you can raise a hand and say answer, and you will get stickers. Let's say because I have stickers and 2 pins, so that's it. Then we are looking on the date when it was updated, the recent update. It's pretty important, but still not the major value because it could be something written in Dart. And if it was updated with the new Dart language, so Dart 3 compatible, then maybe it makes no sense to update it again. But probably after Dart 3.7, it makes sense to update it again. So important and somehow valuable thing. Moving forward, we have, what is that? Yeah, repository homepage, kind of documentation, cool things to navigate, to check it out, and to kind of understand what it is about, what the issues are, and other things. Issues are important because in GitHub you can find out how this developer communicates to the community, how this developer solves the issues, how fast. Probably there are some issues which are opened like many, many years ago and still not even answered. It happens. So please check this out as well. Yeah, moving forward, scrolling down, let's say. Scrolling down, we can see here, I can barely see it, documentation. If it is complex API, definitely documentation should be there. If it is something simple, math, which says like A plus B equals C, then it's a really different story. So please check it out. Then another one, license. We are in the world of public open source development, but license still exists. And it means you still can use it, you can replicate, even copy it, but please respect some conditions. These conditions are on the license.md markdown file. Please respect that. Then, going forward, we have some packages who depends on this package. That's a cool thing, by the way. If it is really used, if other packages are using this package, that's amazing. If there is no one, probably that's a sign. And the cool thing I've blurred, because I don't really want you to see what are the dependencies, not to blame anyone, but also not to figure out what this package is. But if you will be able to recognize, that's amazing. So these are dependencies we are taking into our application when we are importing the package. And that's all your transient exclamation mark yellow things we are getting into our app. Probably some of them will be malware or whatever. Going forward, it's not it, like pub.dev is amazing. And recently, by the way, I've learned that pub.dev is actually public development. I was like, oh, yeah, really? Because public houses in UK are actually pubs, so it's shortened, so public houses, that's it. Pub.dev is public development. Yeah, what we have here? Here we have quite a frequency of updates. More is better, but like if it is too often every day, probably that's a red sign, and developers are just rolling out every new release with new commit, so not the best thing to do. A minor version, it's still fine if it is 3 to 10, whatever, or 1 to 10, but if it is like 175, probably we need to consider these developers are like just really didn't configure their pipeline. And the changelog, for you to know exactly what's in there. What's changed, maybe you don't really need the latest update because it brings you another thing and you are good with to stuck on a specific version. Anyway, still a lot of information. And we are looking into points. Points are important. They are also set by the community members, this Flutter favorite community. Sorry, need to fix my pin. And these points are highlighting some weak points or strong points. I mean, if you have 160, it's actually all points you can get for the package, so it's really cool. Here we are. That's my estimate of how hard it will be to maintain the package if you will decide to bring it into your application. And more or less, if I can read, if overall complexity of the package is not that big, probably maintenance cost is not that big. Higher complexity, higher maintenance cost. Oh, sorry, it's too fast. Then, how old is the code? So you need to update the code. How many issues still open? So probably it's kind of for you a sign that it's still not complete or it's still not at the stage you can use it. Then, how many dependencies it has? So more dependencies, harder to maintain the application because you're bringing new stuff, and then you have a conflict of dependencies, and then a lot of interesting things happen. So you need to pick and stuck on specific version of package, just not to bring dependencies and not to resolve these dependencies afterwards, conflicts. And the last is native code, because five platforms, I think, for all of them you can have a native code. If it is simple, more or less fun. If it is something more complex, that's a bit hard to maintain. So it's a bit more complexity because you need to know Android, iOS, web, Linux, macOS, whatever, like a lot. Windows, you need to maintain that. And that's a step before the next chapter. So that's like a conclusion before the next chapter. Next chapter is dependency trap. What happens if we have this dependency, and what if we really have the product in release now, and this product need to be updated, but these packages are not supported or whatever? And that's where actually this talk was born. I was speaking to the community, And that was my post. I did a mistake there, but yeah, don't get me wrong. It sounds like what a situation where you had application and you were a bit disappointed about the code because you have a lot of dependencies and these dependencies are everywhere. So it's really hard to replace anything. Whatever, package is abandoned, package is discontinued, but you have it in the code and it's just everywhere. So as a surgeon, you need just to cut it off. And I got some responses. Happy to hear that from community. Friends of mine, some Android GDs even. They are speaking about UI. They are saying about some static things. I'm not going to point at it, but you can probably figure it out on yourself, on your own. And kudos to Tom. He says, is it React Native or something like that? Yeah, it's not, but yeah, React Native has probably the same issues, I guess. So anyway, kudos to all the people who were interacting with me under this post. Andrei, Tom, Oscar, and Mark, yeah, kudos to you. Then, summary is here, of course. I've heard, I did a summary, and I want to share this summary with you. So, reality is the next. Packages can speed up development, right? They can provide you battle-tested solutions because it was already tried by someone. And they can help avoid reinventing the wheel, means it was already done. Why should we create it again and again? But sometimes packages becomes liability. Liability, like, now it's yours, so you need to deal with that. And how to avoid this situation? Or let's say, how we are dealing with these liabilities. There are quite a few things. Evaluation, that's what we did before. Evaluate what we have, what we are bringing on board. Then fork and modify, if you can. So actually modifying for your needs, just having the stuff you really need because package doesn't bring it to you. So you're like, okay, I can do this math here and it will work. You can also copy and simplify. It happens. Yeah, you can copy, license allows that, but please respect the license still. License.md. And also build in-house solutions. I mean, if your company have a lot of money and you have a lot of time and so on, so publicly released application, but now you have time to deal with technical debt. So cut off the dependency, build your own thing, and handle it. Go for that. Why not? But before that, we need also to introduce at least some structure, because if dependency is everywhere, the structure is really needed just to cut off one thing and bring a new thing, and you are good. You are not changing the whole code and not having a headache for a while. I will give you an intro to ports and adapters. Just one slide. Here we are. Hexagonal architecture. Finally, we get to the point where it has something connected to the ring, to the wrestling, though in octagons, people are not able to throw anyone else outside because octagon is really protected. And in wrestling, it's a square or rectangle, so we are somewhere in between. So we are playing hard, but still able to throw guys from out of the rings. And this architecture offers you a few things. I mean, core, of course, is your code. The code you written, the code you own, the code you know, so you can manage it. Then ports. Ports are a bit of entry and exit points, so it is on the edge of your application. And adapters. Adapters are actually guys who deal with the outer dependency, external dependency. So they transform external to internal, and you can access them via ports. So please check it out. It's made by Alistair Cockburn, taken from Wikipedia, interpreted by me. It's a shortened version, but image is taken from Wikipedia. Here we are. Just a bit of intro. It is about hexagonal architecture. Now it is official. Now it is publicly known by all the people who are actually watching us online. I hope you already woke up, maybe a time difference, but let's start the process. That's the most interesting thing, or maybe most valuable. We will start with the simple things. And there are a few ways to throw dependencies out of the ring. And probably it's not that easy to do with UI. UI is kind of something you're just injecting in your own application, and that's it. It's like to be displayed. So that's the most user-facing thing. But there are still some things you can do. So let's go. Oops. Wrong one. Wrong direction. UI. Third thing you can do is actually just wrap external dependencies into your internally visible things. So keep it closer to the design system, not in your application. I hope I highlighted it. Anyway, so keep it on the edge in a way that you're dependent on the design system. Design system wraps the external UI, and your application is a completely separate thing which depends on design system handled by you. And then in design system, you can easily replace one dependency with another. So easy win, let's say. Why wrap UI? Yeah, that's actually what I explained right now. Keep it on the edge, and then make them easy replaceable. But still expose publicly the same API, or at least API you really need in your application. Another thing, what you can do, you can take one package, check the source code, and then say, oh, I don't really need all of that stuff. I just need this simple class, and then just grab it. As I said, there is a license. Please respect it. Please also keep a copyright. And also, yeah, if you can, just buy these guys a coffee online, whatever. Just make your own UI. Still try to keep it on the design system. Do not bring it to your application directly. But that's pretty it about UI. That's how it works. That's for my friends, Adrian and Francois. Kun is here. Yeah. Let's grab any piece you need. Here we are. Now the hardest. Now the hardest, that's actually where we have all these ports, adapters, this madness. Let's go. Let's go. It's not that much because I'm not showing all the code, of course, but I'm still highlighting things we can handle easily. Routing, navigation. Instead of having all over your code, up router, go router, whatever router, navigator router, you can use your own internal. You can call it domain router, but I decided not to call it domain because you'll say, oh, it's clean architecture. I told you. No, it's not. It is your internal router, which has some connection to adapter, and this adapter deals with external dependency. And actually, internal router just gives you the API. I mean, it's an interface. Actually, any class is implicit interface. So it gives you connection, API, method, whatever. And then, via adapter, you can navigate to the place you need. Let's check it out, what this adapter is. So this is external navigation adapter, which takes external dependency into and transform your internal things to external things and do the stuff. Vice versa, you can actually replace the thing and it will be external new navigation adapter. It will do the same things, but with a different API. Highlighting points. As you can see, this adapter has external dependency inside. Here we are. And then you can probably find out the projector because I decided to follow the solid principles, so single responsibility. Adapter is not responsible for transforming the external and internal data. It is responsible for connecting them, but roads, internal to external, can be projected somehow. So it's just a set of data to be projected on the different light, as we do have right now. And this is a projector. Pretty simple and amazing thing because you can have an extension function and this extension function can be tested like super easy. That's where TDD is like shining. That's where I was like, wow, I can do that. I'm not that dumb. Here we are. This is a projector and it actually just takes whatever internal route and projects it to the set of data you need externally. Super easy. And you don't have to clean it up, all the external roads everywhere. You just need to deal with your internal things. That's how the schema looks like. Luckily, this is unidirectional. So, internal talks to adapter, adapter delegates the roads transformation to another thing, and then goes to the external and says, like, yeah, deal with this now. That's your responsibility. We are not really, we don't really know what external is doing because it's a black box for us. Here we are. That's a cool example, though it's not mine. I borrowed it from another smart developer. So I just want to show how easy it is to get rid of some external things like networker. Oh, by the way, it's getting hot here. Amazing job, but I need to take it off. So I think it's right time now. Here we are. That's an adapter. That's a single function which gives you your internal HTTP client, and you don't care about external one. What it has external as an input, external as an output. Here we are. We are just taking all the external responses with external requests. I mean, doing a request, getting a response, transforming it to internal, and internally we can do whatever we want with our own classes. So whatever we want with our own data structures, whatever. Super easy and super neat, and also you're exposing your own exceptions. Here we are. And now, finally, we're at the stage of ports. So we have all our adapters. We have all these fancy things, but we need to inject them somehow into application. In our case, in this case, I'm just declaring some wrapper as app dependencies. You can do whatever you want. You can use any other dependency injection thing, or you can use provider, river pod, doesn't really matter. You can use it for state management thing for injection as well. But I'm just declaring another class outside. It keeps all the adapters, and that's our port. This port provides all the abstractions to us, and we are dealing with that. Pretty neat. What I want to say on the schema, so external router, it's really outside. It is adapted by our own router, and our own router ported into application via application dependencies, and then whatever it is DI, whatever inside, you're having fun, and you can call it from UI model. Yeah. So that's a way for external dependencies not to pass into your code, not to be spread over the code base, and not to deal with these afterwards. I think, and I see it this way, but that's not it. That's not it. We still can do better in some places. Please try to use extension functions if you want to encapsulate some provider, river pod, dependency management systems, I mean, other things. Whatever is bound to the context, whatever is bound to something else, you can do it with your extension functions. And here you can see like localizations, provider, maybe something else, right, here. Finally, it is super dumb test. I told you I'm not really fan of testing, but I did it, and just take it easy and test it easy. So instead of injecting real dependency, external dependency into our test, we're just abstracting it with fake. Why fake? Fake allows us to declare functions and then just to inject responses, requests, whatever we really want. So we are saying like, oh, this guy works. It works somehow, but we expect it to get to return us this. That's pretty it. And then in this case, you can test your adapters. And your adapter takes this fake dependency, and then you're doing something with your adapter. It's super dummy, as I said. It's just like checks the navigation stack. But you're not testing real navigation. You're testing your adapter. And if your adapter passes this stuff to the external, you will get the data. You will get it in the test. Pretty neat, I think. Another one. Yeah. I think that's pretty it from my side. Thank you.
I'm not going to sing.
This one.
Thank you so much, Vadim. He asked a question.
Did I talk too much, really?
No, you didn't talk too much.